Students, today we will learn about multiplexer. We will learn about the design of multiplexer. So, before proceeding, I would like to tell that this lecture is particularly to understand how physically the multiplexer works and what is its purpose. Okay, and I will tell you the fundamental of multiplexer by the help of decoder. Okay, so in case you don't know how a decoder works, then you can check out my that lecture first. Right now, I will proceed. Now, to learn the multiplexer, there is a simple analogy. Okay, suppose that there are n water pipes coming from some source. Okay, and we want to select any one pipe for water outlet. What we can do? Okay, we can apply faucets or taps to the pipe. Okay, and whichever faucet is open, the water will come out from that pipe only. Okay, the analogy is same of multiplexer. So multiplexer is a combinational digital device or circuit by the help of which if there are n input lines are coming like that of water pipes and wires you can assume, okay, from any source, and we want to select any one input line at a time to proceed further. For processing, we want any one input line, okay, then we use multiplexer. Okay, and other input lines are inhibited. It means if there are n inputs to a multiplexer, only one output will be there, which we will select out of all those input lines. Okay, and that selection is done by the help of a selector switch. Okay, so this is a decoder. You can see 2 into 4 decoder. Two input lines are there and four output lines are there. And we know this thing that by changing the inputs, we can change the outputs. And in the output of decoder, there will be zeros and one, but only one high or one will be there. It means suppose I say that inputs are 0 and 1, 2 and B. Then you can see the outputs are 0, 1, double 0. Only one high, one output is 1. Okay. And in case I change the input, you can see that the position of 1 has been changed. Similarly, you can see double 0, then 1 is over here and 1 is over here. Okay. Now these are the four input lines coming I1, I2, I3 and I4. Okay. And data is coming from all these and I want to select any one input line for further processing. Okay. So this is the decoder. How I can do this? See, I have applied four AND gates. Okay. These AND gates are of two inputs and one by one I am feeding all the input lines I1, I2, I3, I4 to these AND gates. So one input is the input line coming from the source and other input of the AND gates are the output of this decoder, you can see. Okay, so what happens, since the output of the decoder, any one output will be one at a time, others are zero, so only that AND gate will be active, others will be inhibited, because any one input of an AND gate is zero, then AND gate output is always zero. Okay, so further I will use an OR gate. All the outputs of these AND gates are applied to the OR gates and this is the final output. Why? Because any one AND gate will work at a time, so from that the data will go to the OR gate and it will output the data which is coming from there. Okay, so suppose I say that 0 0 is the input to A and B. So when 0 0 will be input, this will be the 1, this output is 1, so this AND gate is active now. Okay, so it means what, this and the other input of this AND gate is I2, you can see. So 1 is obtained from the output of this decoder, and in suppose I say from I2 the data bit is coming 1, so 1 1 output will be 1, so ultimately we will get 1 at the ultimate output. Okay, so it means what, over here this decoder is working as a selector, that which data line I will choose for further processing. Furthermore, suppose I say I have changed the inputs 0 and 1. Now this is 1. So this AND gate is active, others are inhibited. So one input which is coming from I3 is 0. So 0 and 1 will make 0. So ultimately the I3's data will go out through this OR gate and it will become the ultimate output. Okay. Now this is the actual circuit diagram of 4 into 1 multiplexer. You can see 4 data inputs are coming, I1, I2, I3 and I4. Okay, and this is the ultimate output Y. Okay, now you can see there are 4 AND gates with 3 input lines. Okay, and one of the input is the input line itself. You can see I1 going inside this AND gate, I2 to this AND gate, I3 to this AND gate, I4 to this AND gate. Okay, and these are the selector switches. Okay, so these S1 and S2 can be 0 or 1. Okay, S1 line is this and a NOT gate is applied, so the output of NOT gate will be S1 NOT. Okay, so S1 line is this and S1 NOT is this. Similarly, S2 line is this. Okay, and S2 NOT is this. Okay, so you can see that to these AND gates, in case I take the first one, Then one input is this I1, other input is the S2 naught. This red dot is for connection, and the third input is S1 naught. And for the second AND gate, you can see one input line is I2, other is this S2, and the third one is S1 naught. Similarly, for this third AND gate, you can see one input line is I3, and one is S2 naught, and other is S1. And for fourth one is I4, and one is S1, and other is S2. Okay. Now, suppose that I1, I2, I3, and I4. Suppose I1 is 1, suppose, and I2 is 1. Data is coming from I1 is 1, I2 is 1, I3 is 1, I4 is 0. Okay. And I have to select only I1 for ultimate output. What I can do? I can go like this. These yellow lines are for 1 and black for zeros. Okay. So in case I am inputting to the selector S1 0, okay, then this line will be 0. Output of this NOT gate will be 1. Okay. Similarly, S2 is also 0. I am taking S2 as 0. Then S2 line is this, S2 naught is this, so S2 naught will be 1. Okay. So we can see only this first AND gate is getting 1 from the selectors. Okay. This first AND gate is connected to S1 naught as well as S2 naught. So all the three are 1 now. You can see I1, S1 naught and S2 naught. So from this AND gate, the data will come out because all the three are 1. So 1 is coming out and passing through this OR gate, ultimate output is 1. Others are inhibited. Reason being, in case any one input of an AND gate is 0, then output is 0. So only I1's data will pass through and others data will not. Similarly, in case I am changing the selectors, okay, in case earlier S2 was 0, now it is 1. So 1, in that case S2 naught is 0. Okay. Now we can see that this second AND gate, okay, is getting all the three inputs as 1 because second AND gate is connected to S2 and S1 naught. Okay. And I2 is coming 1. So ultimately from this second input line, the ultimate output we will obtain. Okay. Like this, we can change the data bits of S1 and S2 to choose the input line from where we want the ultimate output. Okay. So by this small lecture, you would have understood that what is a multiplexer, how it works. Thank you.